What you're about to see shouldn't be possible, but it is. Science is built on rules, laws, predictions. We learn that gravity pulls things down, liquids flow, and solids hold their shape. But what happens when science seems to break its own rules? When reality just ignores them? Today, we're diving into 6 scientific phenomena that don't behave the way they should, and yet they're 100% real. Prepare to have your mind bent. First up, let's look at ferrofluid. At first glance, it looks like an ordinary black liquid, maybe oil or ink. But introduce a magnetic field and things get weird. The fluid erupts into a mesmerizing display of spikes and crests, like a living sculpture from another dimension. It's not just a puddle anymore, it's an entity that dances and writhes, following the invisible lines of magnetic force. The liquid defies gravity, climbing up the sides of its container to reach the magnet. How is this possible? Ferrofluid is a colloid, a liquid filled with nanoscale magnetic particles. Each tiny particle is coated with a surfactant to prevent them from clumping together. When a magnet comes near, these particles align with the magnetic field, and the liquid itself takes on the shape of that field. It's a perfect blend of fluid dynamics and magnetism, creating a visual spectacle that looks like something straight out of science fiction. It's as if the liquid itself has come to life, responding to an unseen power with incredible precision. Next, we have the bizarre world of non-Newtonian fluids. You probably made this in science class as a kid. It's called oobleck, a simple mixture of cornstarch and water, and it completely breaks our understanding of what a liquid should be. When you move your hand through it slowly, it flows just like water. It's a perfectly normal liquid, but try to punch it and it instantly becomes as hard as a solid. You can literally run across a pool of it as long as you keep moving fast. The moment you stop, you sink. This happens because the cornstarch particles are suspended in the water. When you apply slow pressure, the particles have time to move out of the way, allowing the water to flow. But when you apply sudden, strong force, the particles jam together, creating a temporary solid structure that resists the impact. It's a fluid that decides its own state of matter based on how you treat it. It's a trickster, a shapeshifter, and a mind-boggling example of physics at its most playful. Now, let's journey to the coldest temperatures imaginable to witness something truly astonishing: superfluid helium. When you cool helium down to just a couple of degrees above absolute zero, it transforms into a state of matter with zero viscosity. That means it flows without any friction at all. Imagine a liquid that, once you stir it, will just keep swirling forever because there's nothing to slow it down. It's a perpetual motion machine in a beaker, but that's not even the strangest part. Superfluid helium can do things that defy gravity and common sense. It can crawl up the walls of its container and escape, as if it's actively trying to find the lowest possible energy state. It can flow through microscopic cracks that are completely impermeable to any other substance, even gases. It moves as a single, coordinated quantum entity, a wave of matter rather than a collection of individual atoms. Seeing it in action is like watching a ghost in a machine, a substance that operates by the spooky rules of the quantum world made visible on a macroscopic scale. From the quantum to the biological, let's watch something we see every day, but rarely appreciate: the secret life of plants. We think of plants as static, unmoving objects. But speed up time, and you'll see a hidden world of constant motion, a silent, graceful dance that happens too slowly for our eyes to perceive. Through time-lapse photography, we can watch a seed sprout and twist its way out of the soil, reaching for the light like a determined arm. We can see vines and creepers actively exploring their environment, sending out tendrils that coil and grasp onto supports with surprising speed and precision. Flowers don't just open, they unfurl in an explosive, symmetrical bloom, a daily performance for the sun. Leaves turn and track the light throughout the day, like tiny solar panels optimizing their energy intake. This isn't random movement, it's a complex, programmed behavior driven by hormones, light, and an internal clock. It reveals that plants are not passive decorations, but dynamic, living organisms actively fighting for survival and dominance in a slow-motion jungle we never get to see. Now, let's revisit that idea of time-lapse plant movement, but this time, let's focus on the more aggressive, almost intelligent behaviors they exhibit. It's not just about reaching for the sun. Some plants are hunters. The Venus-like wrap, for instance, lies in wait with its jaw-like leaves wide open. When an unsuspecting insect touches its trigger hairs, the trap snaps shut in less than a second, a speed that's shocking for a plant. It's a calculated, mechanical action. Then there's the daughter vine, a parasitic plant that acts more like a predator. It can smell its host. Time-lapse shows it casting its tendrils out, sniffing the air for chemical signals released by nearby plants. Once it locks onto a target, it grows directly towards it, wraps itself around the victim, and inserts specialized structures to suck out its nutrients. It's a botanical vampire. Watching these processes sped up reveals a world of competition, strategy, and survival that's just as dramatic as anything you'd see on the African savanna, just played out over weeks instead of minutes. Finally, let's make sound visible. We think of sound as something we hear, an invisible wave traveling through the air. But what if you could see it? This is the field of cymatics. By vibrating a plate covered in a medium like sand, water, or powder, we can visualize the intricate patterns created by sound frequencies. As the frequency changes, the patterns shift and transform in real time. A low frequency might create a simple, symmetrical shape. But as you increase the pitch, the sand or water arranges itself into stunningly complex and beautiful geometric mandalas. These aren't random designs, they are the physical manifestation of sound waves. Each frequency has its own unique visual signature. It shows us that sound is not just an invisible force. It has a tangible, structural effect on the physical world. It's as if we're seeing the hidden architecture of music and vibration. Cymatics reveals a fundamental connection between waves, matter, and geometry, turning audio into visual art and proving that there is a hidden order and beauty in the vibrations that surround us every moment. From a liquid that becomes solid to a fluid that defies gravity, and from the secret dance of plants to the visible geometry of sound, we've seen that reality is far stranger, more beautiful, and more complex than we think. The rules we learn are just the beginning. Science is only just starting to understand the deep, and sometimes bizarre, principles that govern our universe. If this broke your sense of reality, wait until you see what we have next. Hit that subscribe button for more scientific shocks, and thanks for watching.